Germination editor Mark Zinkowitz. The Canadian Plant Breeding and Genetics Award is sponsored by Germination and Seeds Canada and is presented each year to a public or private sector researcher who has made a significant contribution to the advancement of Canadian plant agriculture through research in plant breeding and genetics. This year's recipient is Istvan Rajcan, professor and soybean breeder in the Department of Plant Agriculture at the University of Guelph. His practical approach to breeding has generated a large, broadly adapted germplasm base. This germplasm has yielded varieties with leading market share and has also served as a genetic resource for many other public and private breeding programs to use in their research and crosses. Istvan's germplasm is now present in a large percentage of commercially successful soybean varieties grown in eastern Canada. His products have also been produced beyond Ontario in Quebec, Manitoba, and Eastern Europe. They've also gained a high degree of recognition with soybean end users throughout Europe and Asia. During his time with the University of Guelph, Istvan has also been a mentor to many graduate students and several plant breeders who are now active in the industry themselves. Istvan, congratulations on your award.
One is the number of soybean cultivars that have been developed under my leadership with my research team, which is close to 70 over the years. I'm proud of that, in that those cultivars, not all of them were taken up with the same enthusiasm. Some of them stayed in the market for much longer than others. That's normal in plant breeding. But the fact that they have been relevant all these years to Ontario farmers, and they have also been grown by farmers in Quebec and Manitoba over the years, and more recently in Europe. I'm lucky in that some of my colleagues in the public sector don't have the ability to develop cultivars. They may be teaching plant breeding courses, but they may not have an active breeding program. I've had the luxury of and privilege of actually having an active and dynamic breeding program that leads to cultivar development, and the university is good at commercializing those cultivars. There was a breeder for what was then Pioneer Hybrid. Now they are Corteva. Many years ago, I think he worked in the Woodstock area in Ontario by the name Vladimir Pushkaric. I don't even know that gentleman. I never had the pleasure of meeting him. He was originally from Croatia, and he worked as a maize breeder for Pioneer for many years. What he said, or I may have seen his interview online, I'm not sure, but what he had said at the time was to be a successful plant breeder, you better know who your customer is. And I couldn't agree more, because if we can do things that are fun for us, and you can spend a lot of time and effort and hours, developing a cultivar that nobody wants, and then all that effort would be wasted. Funding. When I talk to my colleagues in the US, and I mentioned to them that we have, both at the provincial and federal government level, multiple funding opportunities that are based on an industry match. So you have an industry funding partner who provides a certain level of funding, and that is matched by different levels of government, sometimes 2 times, sometimes once, depends on the funding program. To my knowledge, they don't have something similar in the US. It's either government funding or industry funding, but not both. So it is our advantage to have that. But I think we may have a little bit too much of a focus on those funding opportunities, and not enough focus on fundamental research that is just government funded. because if the government doesn't do that, the industry is not going to come to us as researchers and say, we want you to do this fundamental research, which may yield results in 20 years. Forget it. They will never do that. So however, if those fundamental technologies are not developed, they will not lead to applied technologies. So there are some funding opportunities such as NSERC and Discover grants and also CIHR and other organizations that don't require a researcher to have a funding match from the industry. But often those grants are small. You may hire one student or two students, and that's not enough to build a large and dynamic program. So if somebody came to me and said, what would you change? I would like to see a change in the level of funding for fundamental research that is not dependent on, profit-driven private industry needs. Thank you for that question. Yes, I would say if I had to pick one variety of all the ones that have been developed under my leadership, it would be OSC Wallace. And OSC Wallace, it's still grown by the farmers. It was one of the first varieties that we developed in the program since I started here in 1998. I think it was registered maybe in 2001. And so it's been grown now for 20 years. And as I like to say to my students, there's often in genetics and breeding, there's often varieties who are that are racehorses and workhorses. So the workhorses may not be in the top of the list, but they are stable and their performance doesn't deteriorate substantially over the years. And the racehorse horses may be really topping the charts of the variety trials for a couple of years, and then they bomb. They disappear from the market. Every now and then, one is a breeder is able to come across the genetics that is both stable and high yielding. And OSC Wallace was one example of that. There are now better varieties and higher yielding than OSC Wallace, but it was dominating the maturity group table with data from Ontario for good 10 or 15 years. It was very difficult to beat. So even for myself, sometimes I was frustrated. I'm trying to do something better than OSC Wallace, and it's hard. If I had to say one technology that would make a huge difference for soybean breeders and is still not in place is a double haploid technology. That's been tried and no one has succeeded in developing a double haploid technology for soybeans. The canola breeders, wheat breeders, maize breeders, they've been enjoying the benefits of double haploid technology and what it can do in terms of shortening the breeding cycle. We don't have that either in soybean or a common bean, unfortunately. So if someone developed a double haploid technology, I think it would lead to more progress in plant breeding.